Alright, so welcome to the primitive data types parts 2 of the TypeScript tutorial. So today we'll discuss the following data types. First we'll talk about arrays, which are used to store multiple values in one single variable. Then we'll talk about tuples, which is an array where the element's type is known but not necessarily the same. After that we'll talk about enums, which is a way of giving friendly names to sets of numeric values. We'll talk about any, which is a way of describing a variable type without knowing it while we're coding our application. And finally, we'll talk about void, which is just the absence of having any type at all. So let's jump into a code editor and start having some fun. Before we jump into arrays, I should mention that although this is part 2 of primitive data types, I went ahead and I created a new directory and a new file for this, just so we can start off with a clean slate. And as always, I will have the link to this code below the video. Okay, so as I already mentioned in the introduction, arrays are ways of storing multiple values of a certain type in one variable. Okay, so you can think of them as continuous lists of data, and in fact in some languages like Python, arrays are called lists. Okay, so in TypeScript, array types can be written in two ways. The first way of doing it would be to declare your variable or your array with a name. So let's say let number array be of type number, and then you would follow that with the square brackets. So this essentially lets the compiler know that this is an array of type number, and then you would simply initialize it with whatever data. So it can be 10, 20, 30, 40, and 50. So now we have a list of integers. Okay, and then in the same vein, you can have a string array as well. So let string array be a string array, right? So this again lets the compiler know that it's a string array, and then you would just initialize it to some data. So Bob, let's say Sam, Lucy. Okay, so now you have a list of an array of string data. Okay, so that's one way of declaring your arrays. The other way of doing it would be to, so for example, if we were to kind of reformat this number array here, you would declare your number array here, but now in this case you would actually declare this variable to be of type array, but then you would follow it with caret braces here, and then inside of the caret braces you would put in whatever type this array is. So this array would be of type number, and then you would close off the caret brace here, and again you would initialize it to whatever list. So in this case it would be the 10, 20, 30, 40, and 50. And same goes for a string array as well. You would just have an array, follow with the caret braces here, and then inside of the caret braces you would have it as a string, and then you would initialize it to this list here, the Bob, Sam, and Lucy list. Okay, so this is equal to this. Okay, so it's up to you as to which way you find more convenient. Because of the fact that arrays are lists of data, you can access each individual piece of that data by its corresponding index number. Now, I'm not sure if I mentioned this in one of my previous videos, but indexes actually start with the number 0, not the number 1. So for example, Bob is sitting in an index 0 and Sam is sitting in index 1. Okay, so first of all, let's get rid of this duplication here. And now if you were to try to access the number 30 here, you would need to access it via its corresponding index number. So in this case it'd be 2. Okay, so you would simply just write out that array, so number r, and then you would access that particular number here, 30, with its corresponding index number, so 2 in this case. Okay, so this little piece of code will essentially return the number 30. Okay, now let's log this out so we can see it on the screen as well. Okay, so I'll just pass this into our console log function here. Okay, and now save it, and we can compile it, and let's actually run the watch feature here as well. So let's not sure if I have, I only have one thing here, so let me add another terminal here and just run the watch feature on our compiler. So again, it'll be watching for changes. Okay, then we go back to our original terminal here, and now what we can do is we can just simply run node on the basic types p2 JavaScript file. Okay, and there it is right here, 30. So arrays have a plethora of different functions, and in this video I'll show you a couple of them. Okay, so let me just comment this with array functions. Okay, here we go. So the first thing I'll do here is I'll actually create a new array here. Okay, just to sort of just so we can play with this array here. So let's go ahead and create a couple of cars here. So we'll have an array of type string, and we will have a bunch of cars. So let's start with Toyota. We'll have a Toyota, we'll have a Buick, let's say. What else? There's a Ford. We also have a Jeep. And let's finish it off with Honda. Okay, so now we have an array of a bunch of cars. Okay, now if we console log this array, we should see these cars here, this list. So save it, run node, and there it is, right? So we have the Toyota, Buick, Ford, Jeep, and Honda. Okay, so we have our array. So let's start playing with it. Now, just like you could access the number 30 with index 2, we can also change that particular element with whatever new piece of data we're trying to pass into it. Okay, so let's change our Buick to a Mercedes-Benz. So a bit of an upgrade, I guess, here, right? So Buick is its index is 1, so it'll be cars 1. Then you would initialize it or reinitialize it with a new element or data. So for example, let's say we're upgrading it to a Mercedes, and hopefully I can spell correctly here, Mercedes-Benz. Okay, and now if we save it and run node again, our Buick is now a Mercedes-Benz. Okay, now we also have a delete keyword here, so you would write out delete cars, and we're taking out the Mercedes-Benz because we can't pay for it. It's too expensive, right? So now we're taking out this this element here, our Mercedes-Benz. So we save it, we run node again, and now we have a Toyota, and then we have an empty item. Now, admittedly, this isn't the best way of doing it, just because you effectively leave an array that isn't complete, that it actually has an empty item that you can no longer actually refer to. Okay, so you effectively have like this broken array at this point. It still functions, it's just a bad way of doing it. And I will show you a better way with either pop or shift, but that's in just a minute. Okay, then what we also have is we have a push. So let's say you would want to add something to that array. Okay, you would simply just write out cars and then dot push, and just like with strings, you would have with any object in TypeScript, you would have kind of like native functions that are a part of it. So dot push is a native function that belongs to an object array. Okay, so you would simply put in whatever data you would want. So let's say we are adding a BMW to our collection. Okay, save it, run node again, and now we have our list plus BMW. Okay, so that's push. Now if we were to try to pop it, and that's a better way of deleting something from an array. If you actually want to get rid of this BMW element here in this array, you would simply just pop it, because what pop does is that it pops the last element in an array. Okay, so you would go with cars.pop and save it, run node again, and now we're back to Honda being the last car. Okay. Then we also have unshift. Okay, so what unshift is you add a new element to the beginning of the array, right? So pop, you're taking you're taking out the last element. Unshift, you're putting an element to the beginning of that array. Okay, so it'd be cars.unshift, and then you're putting in something else. Let's say a Lexus in this case. Okay, you save it, and now if we run node, we now have a Lexus in the first spot, and everything else was moved one index to the right. Okay, so now Toyota is in index number 1, and then Ford is index number 3, I guess. Okay, so that's unshift. Then, as you might have guessed, we also have a shift. So what shift does is it simply removes the first element from the list, from the array. Okay, so if we run shift, just like with pop, what it did is that it removed the last element. Shift, it removes the first element. Okay, so if we save it and then we run node again, now we're back to Toyota being the first element here in this list. Okay, so if you are trying to sort this array here, you could also go with the sort function. So cars.sort. Okay, save it, run node, and now it sorted this array. So Ford is now in index 0, and then you followed by Honda, Jeep, Toyota, and then the empty item. Okay, and obviously it's sorted alphabetically. If it's numbers, it'll sort by the number height, right? Okay, so let me just go ahead and comment these guys out here really quick. Okay, next we have concatenating arrays. So just kind of merging arrays, merging different arrays, right? So let's say we have a bunch of different arrays here. Let's say we have colors 1, and it's a string. And we initialize it to green and red. Then let's go with colors 2 and colors 3, and this can be, I don't know, blue and yellow, and then we can have a purple and white. Okay, so now we have these three different arrays of colors: green, red, blue, yellow, purple, and white. And if we have another array here, and let's say let combine colors to be an array of type string, we initialize it to colors1. So you are taking this array here, and then you are running the concat function on it, which stands for concatenate. Okay, and then you're passing in the arrays that you're trying to merge together, or that you're more specifically you're trying to merge colors1 with. So in this case, it would be colors2 and colors3. And in terms of the parameters for this function, you can have as many of these arrays as you actually trying to merge together. Okay, so it can be just one, or it can be two, or it can be five. Whatever it is, right? And then if we console log our combined colors, save it, run node again. Now we have green, red, blue, yellow, purple, and white, all a part of just this one array here. So another useful function is the splice function. Okay, so what splice does is it takes out a chunk of your array and only leaves you with whatever you're trying to keep. So for example, let's say that we would want to get rid of everything except the green and red in our combined colors array. The way that we would do that is we would invoke the splice function on combined colors. Okay, and then so splice takes two parameters. The first parameter takes the index number that you're trying to start with. So for example, let's say that we would want to delete everything again except green and red, so you would start with blue. So you would start with index number 2, and then you would put in a number of how many elements you're trying to take out. So let's, in our case, it would be 4, right? Blue, yellow, purple, and white. So again, like so this 2, it starts you off with taking out blue because it's array index 2, and then it takes out 4 elements, so blue, yellow, purple, and white. Okay, so if we save this and then we run node again, now we only see that our combined colors is green and red. Okay, so that's splice. Okay, then we can also return an array or just a piece of it into a new array. Okay, so whereas splice it changes combined colors, we also have a slice. Okay, which actually doesn't really do anything with the array that you're invoking the function on, but it just returns that chunk of array, that chunk of your list, I guess. Okay, so for example, in this case, let's go ahead and let's make a new array here called new colors, and we will only put in a part of our combined colors array. And let me just let me comment this out here. Okay, and we are putting in our combined colors dot slice. So it's not splice this time; it's slice, and we're starting off with index number 1, and then we're ending with index number 2. Okay, so we're slicing just that part of the array. Okay, and then we can log our new colors as well. Okay, so we can save it, run node again, and now our combined colors it's all this, but then our new colors is just red because we started with index number 1, which is red, and then we ended with index number 2, but it doesn't include the index number 2 because it ends before that number, essentially. So in this case, it's just we only returned one element. Okay. Now, so in one of my previous videos about strings, I mentioned that strings they're kind of array-like structures, right? So we can actually have, just like we have functions on arrays, a lot of these functions also work for strings. Okay, so let's have another little section here called strings as arrays. Okay, and let's comment this out. And let me go ahead and just comment out the console logs here as well. Okay. Okay, so I'm just going to clear this out as well here. Perfect. Okay, so so the first thing what we can do is we can also have property access, just like before. Okay. Right, so you would have console.log. You could actually, well, first actually let's make a string. So let's say let hello equal hi there. Okay, so that's our new hello string. So if we say, okay, console log hello, and then we access a particular index, let's say index 4, that should give us the letter T, right? 0 is H, I is 1, the blank space here is 2, then T is 4. Okay, so actually I guess it should give us H in this case. Let's see. So let's save it. Let's run node. Oh yeah, so it's H, right? So it's 0, 1, 2, 3, and then H is 4. Okay, so that's property access. Now we can actually convert a string to an array with split. Okay, so let's say string to array. So let's say we have some string. Just gonna call it lorem, and then I'll just copy my what I have here, this text, because I don't feel like retyping it again. So you know, we have this long text here, and it's a string. But now if we console log, if we use the split function here, so actually not to confuse you with the console log here, let's just delete this. If we have a lorem and then we use the split function, and then we split it with something. So for example, we indicate what character we should split it with. So in this case, a good split would be the blank space. So we indicate a blank space, and we pass this into the split function here. And then if we console log this, we will see that it returns a new array. Okay, so we're console logging whatever this returns here. And I'll be taking this out, save it, run it. So now we actually, what this did is it returned a new array of that the compiler got from this string here. So lorem is now an element in index 0. Ipsum is now an element in index 1. Okay. So that's split. Then we have converting arrays to strings, right? So here we went with string to array. Now what we can do is we can have array to string. So it's exactly the opposite. And for that, what you would do is you would use the toString function. So let's say we have some array here. Let's say animals, and it's a string array. Okay, and then we have I don't know, dog, cat, mouse. Okay. Um, and then you would have another uh, string here, or just a string here. Let's say animals to string. Okay, and this would just be a string, and then we would invoke the toString function on animals. So it'd be animals toString, and we can just close that, and we can console log our animals toString. Let me just comment this out here, save it, run node, and now we have this new string here called animals toString, and it's just dog, cat, and mouse, right? So you know what it did is that it just kind of merged all these different elements into one string. Okay. Now we can also join this thing, right? So what we can do is we can use a little join function. So let's create a new string again here. Let's call it animals join. Okay. And what we can do is this is actually a personal favorite of mine here. This function. What we can do is we can join all of these elements here with something else. So you would invoke the join function, and then you would pass in some sort of a string that you would join all these things with. So in this case, let's say you would join it with chases. Okay. So, and then if we log out our animals join, let's see what we get here. So now we have dog chases cat that chases mouse. Okay, so we simply injected this space chases space into a new string that simply got its data from this array here. So it made a new string that now just sort of combined the dog chases cat chases mouse, and then we created a new string variables animals join. So that's pretty much arrays for you. Now there's a bunch of other functions that I didn't get into, but like I said before, arrays have a bunch of functions, and I would suggest that you would play around with them. Okay, so let's talk about tuples. By definition, tuples are types that allow you to express an array where the type of a fixed number of elements is known, but not necessarily the same, right? So, for example, you might want to have like a value pair that's represented as a number and a string. So let me give you an example. Let's create a new section here called tuples. Okay, just gonna comment this out, and so the way that you would declare a tuple is that you would specify the types of elements that will go into this quote-unquote array, or this tuple. Okay, so you would have, let's say, let tup for tuple be of type, it's kind of an array, but it really is a tuple just because you're specifying what types of like what types the elements are. Okay, so you would have, for example, a number, and then you would have a string. So that's sort of you're modeling that particular data type. Okay, so for example, but now the way that you would initialize it is that you cannot now change the way that it's written. So you couldn't, for example, say tup is now equal to I don't know, like some kind of a string. Let's say I don't know, Fiona, right? And then you would have some number, right? Like that doesn't work just because yes, the tuple takes in a number and a string, but it's important the way that it's actually written, like what comes first, right? So it's important that number comes first. Okay, so for example, see here it gives you an error. type string is not assignable to type number, just because it's expecting the first element to be of type number. Okay, so what would work though is, for example, you would have something like 3 and Sam. That actually works. Okay, so because of the fact that now you have a number and a string in this order, this is acceptable. Okay, now also the way that you would access this, you would access it sort of in the same way as an array. So you would have tup, for example, of whatever index number. So for example 3, and then you could do something with this. So you would say, like the index 0 is the number 3. So you could say something like this, plus 2, and let's give it some let's give it some number. I don't know, some num. Let's say, and it's a number is equal to tup 0, which should be 3 plus 5, and that should be okay. So now if we console log our sum num, okay, we should get the whatever this equals. So 3 plus 5 is 8. Okay, so save it, run node on it, and here it is, 8. Okay. Now you couldn't do that, for example, if you were to access number 1 or index number 1, right? So you couldn't, for example, do this on a string. Well, maybe that's actually a bad example because, yeah, right. So see, type string is not assignable to type number. Okay. Now I wonder what this would actually do. I think that it would still compile. Let's see. See, now you actually get the SAM5. So that's why I said that it might not be a good example, but you'll get the point though, is that it'll give you an error if it sees that whatever you're trying to do with it isn't exactly the data type isn't, it doesn't match the functionality that you're trying to invoke on it. So just to sort of drive this point home, let's erase this, and let's say that you would want to do like run some kind of a string function on a number. So let's say, for example, you would want to run, you would say tup of index 0, and then you would want to I don't know, do 2 uppercase. That wouldn't work, because now it would say property 2 uppercase does not exist on type number. But now if we change this to 1, that's fine, just because 1 is now a string, right? So now it's fine. So now if we actually console.log this, okay, erase this, save it, run it, and now it went from Sam uncapitalized to Sam capitalized. Okay, so that's tuples in a nutshell. It's essentially a way of declaring an array with specific data types. Okay, so like, oh, and like the other thing is that you would not be able to put something else in this array or build this array if it isn't a number or string. So you couldn't add to this if it was say a boolean. Okay, just because the only thing that this array in terms of forming, like putting in new elements here, the only thing that would be accepted is either a number or a string. Okay, so again, that's tuples in a nutshell. Pretty easy. I suggest that you would read more about this if you're interested. Okay, let's talk about enums. So enums are interesting because they are a way of kind of giving you a more friendly way of naming like a set of numeric values. Okay, so let me just let me make a new section here called enums. And let me show you what I mean here. Just gonna clean this up. Okay. All right. So, for example, let's say that to declare an enum, you would just simply say enum, then give it a name. Let's say phones. Then you would list out whatever whatever set of phones these are. So you would, so instead of it being 0, 1, 2, it would be something like an iPhone. Then you would have Samsung, let's say, and a Nokia. Okay. So now instead of this list being starting at 0 and ending at 2, you effectively now have like friendly names for these particular sets of numeric values. Okay. So for example, now if you create a variable, let's say p of type phones, of type of this enum type here, you could simply say phones and then access it with one of these names. So for example, an iPhone, right? And what that should do is it should give p the number of that particular name. Okay, so for example, if we console log p, excuse me, we save it, we run this again, we'll see that it's that p is the number 0, just because it this list, it starts with 0, then it goes to 1 and then 2, but again we're accessing it with these friendly names. Okay. You could also change the beginning of numbering of these values. So instead of it starting at 0, you can actually have it start at 1. Okay, so let me copy this. Or you know what? Let's not even copy. Well, okay, yeah, let's copy this and comment this out, and let's have iPhone start. Instead of it starting at 0, we're starting it at 2. And now this will sort of follow along. So Samsung will now be 3 and Nokia will be number 4. Okay, so we save it, we run it again, and now our iPhone is number 2. But now if we change this to a Nokia, let's say, save it again, run node, it'll be the number 4. Okay, so again, it's just a useful way of playing around with your lists or your sets of numbers. What you can also do is you can actually manually set all of these numbers. So for example, let's say iPhone is number 2, Samsung is now number 5, and Nokia is now number 9. Okay, if we save it, run it again, now we're printing out P, which is the Nokia, which is number 9. Okay. And finally, for example, if you want to go from numeric to string, let's say that you have some other phone name, PN, and this is of type string now. What you can do is you can access phones just like you would access an array. So for example, the number 5 would be, and then let's print out PN here, save it, run node. Now phones 5, which is this number, is now Samsung, just because it actually returned a string and assigned it to PM. Okay, so again, it's just a useful way of playing around with sets of numbers. Okay, let's move on to any. So any is actually an interesting type, just because, as the name suggests, it can be of any type. And you might, wonder why you would even have this. Well, you will, as a developer, you will be working a lot with old JavaScript or just JavaScript in general. And, if you have files, TypeScript files, that then need to work with some old JavaScript library, let's say, some of these objects will need to be able to be passed along as really not knowing what type it is, right? So like you might not even know what let's say you're working with some JavaScript API, what kind of an object you will be getting or working with. So any is a great way of kind of going around this problem. Okay, so for example, let's say so any is just like any other type. The way that you would declare it, you would say let some var be of type any, and let's say at first some var is a string, Sam. Okay, so it starts off as a string, all well and good. Then some var can actually be a would be changed to a decimal. Okay, so this is fine. Like, notice how it doesn't give you any kind of errors. Like, this is still okay. Okay, and now we can actually change this again to, let's say, a boolean. Let's say it's true. Okay. So this is all fine just because of the fact that the any here, it gives you the option of it being sort of a malleable type. Okay, and again, mostly you'll use this with working with JavaScript. All right, it doesn't. So oftentimes it doesn't even check like the methods that you will be passing on to that particular object, that any object. Okay. So again, it's just a useful way of working with JavaScript, but be careful and know exactly what you're doing, just because it kind of allows you for a lot of freedom here, and in TypeScript, the one of the advantages of working with TypeScript is the fact that you are declaring your types on your objects. But in any case, it's useful, and it's something that you will be working with a lot for sure. Okay, so last but not least, let's talk about void. So void is sort of the opposite of any, as in void just doesn't have a type at all. So most of the time it's used for functions, and in terms of variables, it's not even really used, just because the only way that you would use void as a type in variables would be only for undefined or null. So it's something that isn't really used a lot, but it is used for functions though. So for example, let's say you have a function that doesn't return anything, only that it does something, right? Like it logs some sort of a message, let's say. For example, we have a function that says say hello. Then you would type it with the void type, and then inside of that function you would have something, some log message that says, I don't know, hi there or something, whatever it is, right? So this is most of the time when you'll see void. You will see this with functions that don't return much. Okay, and let's just save it and run it for the sake of it. Oh wait, we never actually invoked this function, so let's invoke it here. Say hello, save it, and run node, and there it is. Hi there. Okay, so that brings us to the end of primitive data types. I hope you enjoyed this. I know it was sort of long and a bit confusing at times, and I apologize for that, but I do hope that you got something out of it. If you have any questions, comment below, and as always, please don't forget to like and subscribe. I'll see you in the next video, guys. Thanks. Bye.